right. Good morning, all. As Anbu introduced me, my name is Ananth Pujari, and I am an education account manager at Autodesk right now. I have 20 plus of years of experience, as you mentioned. And of the last 18 years, I'm with Autodesk working in different departments as a program manager, as a technical specialist, and now I'm working as an education account manager where I'm trying to help the education community to adopt the latest technologies that are available or that are available through Autodesk portfolios, and helping the students, educators, especially the students, making them ready for the industry requirements. So here is the quick agenda. Before I just jump into the detailing of these things, again, I just want to confirm, was the audio and my pace is okay, Anbu?
Yes, please go ahead.
Yeah, thank you so much. All right, so here's the agenda that I intend to cover for this session. So the whole objective of this session is to explore the integrated concept of how product design is playing its role for the future of making. We'll look into at how the world is changing with respect to the design and make. So in detail, what we'll cover in today's session is the future of making. And then we'll look at some of the customer success stories, how they have adopted the latest technologies and brought different kinds of products into the market. Then of that little bit non-technical, we'll see how Autodesk is playing its role in the education community. And even like the ICT Academy collaboration sessions, like how we are trying to help the education community in this pandemic COVID situations. And finally, at the end of the sessions, we'll see what are the different takeaways that we can carry from this webinar or from this session. So in this slide, what I really would like to highlight is that how Autodesk is providing the critical insight across all the industry segments. We are talking about the topic called as future of making. The future of making is already here. What we are seeing is the complete convergence of the things, how they are being made, be it any kind of an industry. If you take the architecture, building, or construction industry or infrastructure industry, it's totally changed. The way the things are being made, prefabricated is being the primera of these construction industries, where it's been prefabricated, brought onto the site and assembled at the sites. That's the way the future is looking at it. It's not only restricting to the construction industry. If you look at the media and entertainment industry as well, they are acting like a car manufacturing or car designing companies, where when a car is being manufactured, it's been planned and developed well in advance before a concept car is brought into the market. That's where even the media and entertainment is working towards visualization, entertainment, be it in terms of filming or gaming, plan everything before the actual production is being done. So that's the way people are thinking differently from the future of making. So what is common across all these industries? If you look at it, the basic common thing across all these industries is the design, make, and use. So what we are seeing is the link between the design and make is getting closer and closer and closer. And even the feedback loop from the users is getting tighter. So what does this mean is, like, when the design, make, and use boundaries are being disappear, when the boundaries between these three elements disappear, then we will see a different kinds of products come into the market. What we will see is the real-time feedback from the use and from the and the environment or the system environment. So that's what we will look into it in today's session. How we'll go in detail about how these three elements are differentiating themselves in detail. So first we look at the design part of it. Now, design doesn't mean it's not the traditional way of working in silos. We have a set of design engineers sitting and working on a product, and that product coming into market. Today's world, design means increasing in collaboration. So technology is helping more and more people to come together and collaborate and work on complex projects. And not only that, the crowd funding coming into picture. So the design or the innovation is not just restricted only to the big industries. So it's anybody has an idea, anybody has an innovation can get their product faster to the market. And it's not only that, we have a huge change in the way the cloud computing is taking its power. I mean, what we are seeing is that we can access the data, be it any data or the design data, anywhere, anytime, through any device. So that's the difference, the change that we are seeing in terms of the design. Now when it comes to the make part of it, as I said earlier, that if you look at the construction industry itself, the way the things are being made is totally different. Construction industries are acting like the manufacturing industries, where things are being made well in advance and they are being bought and assembled at the sites. That's the change, that's the future of making. So if I have to take, I'm based out in Bangalore, so if I have to take an example, I'm not sure those who are from Bangalore, they will understand. The previous government has a challenge of building, they had a target of 101 Indira canteens to be built within a 3 months time period. Now if I have to think, if we all have to think, if it has going to be a traditional way of approach in constructing these 101 units in 3 months, it is a big challenge. So we have a precasting fabrication unit near Coimbatore. Then they integrated with us. Everything was pre-fabricated there, and they bought all those things and assembled at this, and they were successfully able to achieve the target within 3 months, building 101 units. That's the change. That's the future of making. It's not only that. If you look at the way the metro constructions was started, like maybe a decade back, so everything was on site. Now today, when we move around across the cities where the metros are being constructed, you see so many fabricated units are being bought and assembled. So that is what I intend to say. It's not just restricted to one industry. Every industry is changing towards that. Now, as I said, innovation is not just restricted to the big industries. There is nothing that we have to build a factory. If I have an idea and innovation to get a product into the market, I don't have to build a huge factory. Micro factories are coming into picture. So if anybody has an idea, they can get their product into the market. And it's not just restricting to the make of it. The make is converted into a personalized touch. Now, if you look at the example here, the headset or the headphones, there is an industry which actually scans your ear and produces these, which exactly fits to your earbuds and gives a high quality of sound. I mean, people are looking into that direction, not at one kind of a mass production. So the personalized touch for the products is also becoming more and more important. Now, when it comes to the phase of use, so there is a deeper integration, or there is a greater connection is happening between the digital and the physical. So what does that really means is the sensors are playing a bigger role as well, and the data that it gets from the things or the products is becoming very, very important for the designers as well as the makers, so they can bring a better quality product to the market. Now, even under the digital environment, what we used to do is when we design our products, it was virtually, we used to just see it on our computers. Now, the 3D printing coming into a picture where my product, I can really touch and feel and see how exactly it looks from all the directions and get the feeling that, yes, this product is exactly the way I have designed it. So what we are seeing, there is a new set of generation of people that are coming and using the designing and making in a different way and getting different kinds of products. So as I said, again, the design or the innovation or the make is not just restricting it to the bigger industries. So anybody has an idea, they can easily get their product to the market very faster. Let us pause a little bit and go back to a little bit of history of how the transformation of eras happened. The first era we saw was the era of documentation, where Autodesk was a disruptive in this era, where Autodesk moved its customers. Autodesk helped the industry from a pencil and a paper to a 2D drawing on a digital environment. Yes, I'm talking about the very flagship product of Autodesk, that is AutoCAD, which is a norm of every industry, small, big, medium, educational, everywhere. Autodesk is becoming kind of a very common product to be used across. So that is the change we saw in the era of documentation. Now, everything was good. It was on a 2D paper. The geometries, the text, the dimension information, everything was accurate, precise. But what really was challenging was like, how can I make a decision, or how can I really visualize my product? That was a big challenge. So everything, that decision was either by intuition or by judgment. So that's how the still a lack in the times of era of documentation. So then we moved from the era of documentation to the era of optimization, where the optimization played an important role, where we moved from a 2D environment to a 3D environment, where digitally we were able to actually see how the product looks from all the different angles. It's not only that, we were able to simulate appropriately, we were able to do the analysis on our component products or the design before it was actually built. So a huge reduction in the prototyping environment, right? So that's, and we had a very good predictive information with respect to the 3D design models. So 3D design definitely gave us a lot of predictive information, profound insights about the design, as well as precision and accuracy. It gave us an information and understanding how the things go together, how the things interact together. That's how the design of the era of optimization took place. And now we are in the era of connection. So what does this really means is that we are going beyond the optimization things. So we have to optimize how the product is built, that which interacts with other systems, which works with the other systems. So that is the change that we are seeing today. Very much the example of how I mentioned the era of connection. So as I said, the physical and the digital are getting closer and closer. So people on the site, on the construction site, are able to use the digital environment. They are using the drones to see the validations, to see the construction site and gather information that are more relevant to build better products, the more relevant for them to think how the future of making can change in terms of the design and make. It's not just restricting to one industry. As I said, even the advanced manufacturing industries are not lagging behind. There are robots being used. There is automation being increased in this. There are 3D printing being increased in this. There are robots, drones are being used to man the factories as well. So all these devices, all these things are becoming a common factor in terms of how the future of making things are being changed. So if I have to explain about this GE example, so GE has built this intelligent system, where secure system, where it collects the data and this system collects the data and feeds back to the rail engineers, who can work on the design and utilize that data and make a better intuition, or make a better design, or make a better assumption of what's happening in terms of this design and make things, so and get a better product to the market, and a predictive system as well. So as I said, the era of connection is so different that the data can be accessed through any means. So it can be through any device and anywhere from any platform. So that's what is the change of era of connection. So we cannot now work in silos or be aversive. The data is available. You can interact with multiple people across the globe and get your things done. Here is a beautiful example I would like to highlight in terms of make. So we have this Lightning motorcycle company where Richard Hatfield is the owner of it. He has 6 people working in the garage, and he always dreamt about the motorcycles and motorcycle designing. So one of the things that he really wanted to do was build an electric motorcycle, and that he wanted to really build in comparison to the combustion motorcycles. So he wanted to really compete his product with respect to the combustion motorcycles that are currently available in the market. So what he really did was, how did he made a difference? How did he was able to successfully get his product into the market? Is he adopted the latest technology. So one of the technology that Autodesk talks about is the generative design. So he implemented generative design in his design process, in his make process, where he manufactured lighter products, much stronger products, and was able to successfully build this vehicle and bring it into the market. So that's the people are differently thinking and adopting the new technology to bring different kinds of products into the market. Now, let us talk about an industry that where the weight carries a major role. Yes, you guys are right that I'm talking about an automotive industry. And what you are seeing currently on my screen is the assembly line of a General Motors. So General Motors always adopted newer technologies and automation in its assembly line to bring different kinds of products, to bring improvements in its products as well. So, and it just didn't stop there. It automated to an extent where what we really see today, can you believe, every minute a car rolls out of from an assembly line. So you can see how they are able to achieve this with the adoption of technology. And it is not just that. If you imagine, if I tell you that, if I tell you that there are 30,000 plus parts goes into a car manufacturing, you can imagine what kind of an assembly line or what kind of technology that they are adopting. So it's making assembly line optimization is not just the way GM was thinking about, because the way the automotive industry is changing in the world, if GM has to cope up with that, if GM have to adapt to those changes, then it has to think differently. So, and since most of the car manufacturing industries are moving towards electric cars, GM also felt that it has to change its innovative business, rethink about how it can bring different cars and work towards the electric cars to bring it into the market. And it is thinking and committed to bring nearly 20 different electric cars into the market. To do that one, if at all an electric car has to be built there, and then there comes also along with that some challenges. The challenge could be like the weight of the battery and mileage. It could be that the safety and lighter weight of the vehicle. It could be like consumer response and affordability. So all these factors comes into picture. So GM has to think differently how it can cope up it and how it can make things different to have those changes in its car and differentiate itself from other competitors. So one of the things that they thought about is, why not adopt a different kind of a technology called as generative design. So now what exactly is generative design? So generative design is nothing but what we call it as a design exploration. Now, if I have to put it in a different way, for example, most of the designers that we work on today's world we call them as a passive, or we are the passive designers. And why do I say that? Is because everything is predefined by myself. I know what my product look like. I know what my design look like. I have all the parameters that I need. And for me, the computer or the digital environment is just acting as a output. So every data that I feed it, it is just giving me a display output. So here, the designers are spending a lot of time, and most of the iterations that goes into it. So the product that needs to come to the market is taking a longer time. So then they thought about, like, how can I change my future of make? How can I change my design aspirations? So then can I throw a challenge to the machine where it gives me an output, and then I decide upon what my design should be or which design I should go after. So that is where the generative design came into picture. I mean, it is nothing but in collaboration with the machine learning. So today's talk is most AI as well as the machine learning. So Autodesk was also not lagging behind. It collaborated with machine learning and built up this fantastic uh, functionality called as generative design, where now I specify certain conditions, I specify certain parameters, and throw away a challenge to the machine saying that, hey, now give me an output based on this. So that's where the machine, which is with the cloud computing coming into picture, the machine learning computers, analyzes its inputs from the designer and throws away. What you see on my screen is different iterations of that one, and gives a flexibility for the designer to choose one among them. So GM wanted to try this experiment in its case, and it came up with this product. What you see on my screen is a different variations, different iterations of the design that they looked at it. You will understand what this product is when I show my final slide in comparison to this example. So here were the different iterations that GM got from its design, and then it decided, and the GM designers were able to validate, analyze which design would be more suitable to them, and they finalized on this one. So this is an actual component that GM is using in its car. Now, what this exact component is, nothing but a seat belt bracket. Very simple component product, but very challenging one. Now, what you see on the right side is nothing but a assembly or a component assembly or multiple components of 8 different components to make one product. And what was the change in future of Make is transitioning from 8 different components into one single product. Now, what does that really mean is, can imagine how much of GM could save in terms of material, in terms of its vendors, in terms of its cost estimation or cost model. So that is what GM felt, yes, this is the change. This is the way we should think about making products going forward. And they finalized upon this product. So now let's look at another example. Okay, this is an Airbus example, again using a generative design case study. Airbus built a bionic partition. You will understand how the design, how the technology is playing its role. Now, what I am restricted to not show the demos because of certain restrictions. You can understand all this is as an output I'm showing as a PPT for you all guys. So where you could understand how the design is iterations, the design is taking place. So even Airbus A320 wanted to try generative design in its case study, and it chose the partition. I'll tell you what this partition is all about. Now, what you see on the screen, it's called as a bionic partition. And what you see on the screen on the left side, where hopefully my cursor, you will be able to see, that's an existing design which has got a complete solid frame that it looks like, which has got around weight of 65 kgs. Now, on applying the generative design, what you see on the right side is the bionic partition with a complete weight reduction of 35 kgs. I mean, what a change from 65 kgs to 35 kgs, 45% reduction in its weight. Now, you may say, what, and here are the different iterations. So you may say, sorry, what difference that would make? Okay, you may say, okay, that's a solid partition, I go up to overhead. One is the reduction in the weight, meaning that there is a lesser material being used in the product. Okay, that is one thing. Second thing, what Airbus was able to achieve is Airbus was able to reduce 465,000 metric tons of carbon dioxide for over a year, which is an equivalent to of 96,000 cars being off the road. That is the biggest achievement that they did. And not only that, one of the things that if we look at how the aero industry works is basically on the fuel consumption. So the larger the weight, the larger the usage of fuel. So with the reduction of the weight, with the reduction of of the fuel. I mean, that's a biggest savings for them. They can save hundreds of thousands of. So these examples, even GM, imagine I mentioned GM applying generative design for one component. Now I said there are around 30,000 parts going into car. Imagine if GM starts applying the generative design, what could be the change in the design? So that's where the technology is moving towards. That's where the things are being made so differently in the world. So we as an educators, we as an trying to bring the students about awareness about these technologies, help them use these technologies and try innovative approach towards their design thinking. Now we talked about the bigger industries. Let's come down to very low level where our education students have applied GD in their case studies. What you see is a quadcopter chassis frame that was designed by our own local Dayanand Sagar University students, Dayanand Sagar Institute students. And what you see on the left side is normally everybody, all of us know about a quadcopter chassis, which has got only a 4-bar frame. Now, how different can I apply? What difference can I make in terms of my product? What you see, the 4-bar mechanism, its initial characteristics, if I look at if I take a material kind of ABS plastics, its weight is around 424 grams, right? Now, when they applied, what you see in the little terminologies of the generative design, when you explore that at the end of the sessions, also we will give you certain links for the courses where you do practice those things. What you see on the left side, green color, is we call it as a preserved geometry, and what you see on the right side in the red is called as a obstacle geometry. So certain conditions that I need to define, and the best part of it is you also can define how it has to be manufactured, whether it goes for an additive manufacturing or whether it goes for CNC manufacturing, and the material, what kind of material and how it transforms with respect to the material that I use in my designs. So what they were able to achieve is the result is this. And this is again an exact solid model that you can download and work on it. So when they downloaded this, they felt at these corners or at these vertices, the weight is very, it's little not the perfect design where it could have cracks or break even for the atom. So that's the reason what they did was, you see, they remodified their design. What I meant to say is that's exactly a different design, a solid model that you can really work on that design. So what they did was they took up the lower frame and made it little robust, made it much more stronger. And what you see on the right side is the complete analysis of that, how the displacement and happens. And not just that was the theoretical part on the digital environment. What actually you see is the actual product that has been completely designed and built and made differently. And this is a flying drone, which was also showcased at Autodesk University. I'm not sure how many of you have attended the Autodesk University. That's the event, that annual event that happens from Autodesk. So these students get to showcase their products into this forum. Let's take another example. I took another example from the same college. This is because here is what you see on the left side is the design from an electronics student. I intentionally took this example because, electronic students are not exposed to the designing aspect of it. So this is what he was able to think from his design perspective. And trust me, he has won multiple competitions as first and second prize using the same design where my cursor is moving. I've given you different variations. Can you look at this design? And what we as a mechanical engineers collaborated with the electronic student and came up with a totally different design. What you see on the right side is a digital design. One is the rendered output, and one where the product Fusion 360 is being used to design, where generative design is being used to design this product. So that's the transformation happened. So it's not just restricting design. Use, make and use is not just going to, any product that comes into the market, it's not one person's job. It's not just restricted to the mechanical. Every person, every department or every discipline can play its role, be it computer science, be it electrical, be it electronics. Everybody has a role to play to get a final product into the market. And what you see is the actual product, which is a fully functional and actual working robot, which runs through, which has got the functionalities that it is capable of doing, that the student thought about it. We also have another example from the student community. IIT Madras has collaborated with the industry as well. I mean, what we saw was the student project, but even collaboration between the industry and the academia is also not lagging behind. So IIT Madras collaborated with Fiat Crystal Automobiles, and they worked on an LCA, lower control arm, and using the concept of generative design. And what way they were able to achieve is again the 26% reduction in their mass. What you see on the left side in the yellow color is the current design, okay, and what you see the transition onto the green side is the green model, is the new concept of additive manufacturing. So that's the change. If you can very well clearly differentiate the model, how it looks initially and how it's being changed to things, and which is much lighter as well as much stronger, as I said, in terms of the percentage. So what I meant to say is that I'm not just talking about the 3D designing or 3D modeling. I'm talking about the technology that people are trying to adopt, people are trying to experiment. So that's where we have to look at it. So that is what was the differentiation for all these companies to differentiate themselves, to be different themselves, to differentiate differently, bring their products to the market. So as a designer, as a product owner, we have to think differently. We have to adopt to the latest technology. We have to help our students understand the latest technologies that are coming into the market, make them ready, make them aware of these technologies, and so that they are ready for the challenges that the industry throws to them. So what it really concludes up to, so it concludes that as the designers, as the product owners, we have to build more and more products to meet the needs of our customers. But how are we going to do? We have to even do with a lesser impact on our planet, the negative impact that is happening across our planet, and we have to build better products, better designs to meet the needs of our customers. So we do with more of the need from our customers, with less of the materials, resources, and a better product out. Now, let me take this. So many companies do come to us asking, hey, how can we be a part of this changing in the world of the future of making? How can we participate in this world where the future of making is completely changing? So we at Autodesk believes that if at all we have to solve the problem of future of making, then we have to have a product innovation platform. We just cannot have the silos of the softwares to work on. So here, if I look at the example where we have the product, the digital data or the data at the center, and how do I transform that data or an idea into a reality is using the designing software. So one of the product that I would like to mention about is the Fusion 360, a completely different product, a cloud-based product which allows you to work completely from your conceptual design till fabrication, everything under one. You don't have to jump or hop from one machine to the other machine, but everything can be done under one thing. So here, if you look at my product, so you have the capabilities of doing the design, you have the capabilities of simulating that product, you have the capabilities of even electromagnetic works, electromechanical works can be done, as well as it has got the PCB design involved in it. So everybody has a role to play using these technologies to make an actual product. We just didn't stop there. As I said, I mean, it's not just about the design. We have to also think about the make as well. So there is a deeper integration. So we have a deeper integration from design to make as well. So CAM, the major requirement for the make is either additive manufacturing or the CAM part of it. The CAM is an integrated part of Fusion 360 product. So where you can very easily transition from your design environment to a make environment and get the actual physical product to be viewed and visualized. Not just that. So it's how the product that I have designed or we have designed and how it is functioning at the field, and that data is being also captured and fed back to the designers and makers, so that there is an improvement, there is a predictive maintenance, you could say, or there is a optimization in their design, or performance optimization, you can say. So all that can be very well maintained or captured. I mean, if you look at nowadays, there are so many there are so many factories are putting sensors across so many components, be it motors, be it any kind of equipment, so that the data is being regularly fed back to the designers or the maintenance unit, so that when they see that there's a chance of that getting breakdown well in advance, that component is being replaced in the complete unit. Otherwise, you can imagine, because of one simple product, the whole production unit or the whole factory may be shut down, and which will be a big loss. So that is the way things are being changed. That is the way things are being made. So that is what I was talking about. We have to look towards the future of making differently. We're just not restricting to one product. Autodesk has a large product portfolios. The reason I'm saying about these product folios is basically you'll come to know in my future slides why I intend to say about these product folios, which you could very well use at your level. We could help your students to use at your level. So what you see, you can even optimize using a product called as NetFab. And it's not that if you want to do certain advanced level of manufacturing, then we have products like Power Mill, which will help you to do this advanced manufacturing. And with Fusion Connect, you can even get how your products are working in the field or in the environments, how it is being used, and get that data and build. So as we at Autodesk feel and how the world is changing, we also changed our product portfolios. We are not just selling one piece of a software or helping students to work through one piece of a software. What we say that if at all I have to meet the needs of the today's change in the future of making, then I definitely have to be a product innovative platform. That is what we intend to bring into this generation. So the whole story lies around design, make, and use, but that is one part of it. But the real power that we have to think about, how can I remake? That is the whole idea about product innovation platform. Imagine if the car can give so much of information back to the designers or the makers, then there could be a different kinds of models that can come into, and we can use the same resources because ours is our exhaustible resources. So that is where not only thinking about design, make, and use, but every industry has to focus on the remake part of it as well. So that was more about the technology aspect point of view. As I said again, I am not able to show them live, but I hope that the information that was fed, how it is, I have tried to capture the design aspect, I capture the technology aspect in terms of PPTs, and trying to help you understand how the transition is happening. Maybe Anbu sir, if you want to put some polls here before, because now that I'm going to go with the slides is little non-technical, where I want to give a little bit of a picture about how Autodesk is playing its role in terms of education, how industry is looking for certain skill sets in the market.
Okay, I'll quickly put one question, and a very, very simple question. I know I'll just start the poll. The question is, do you know Autodesk products are free for education and there is no difference in education and commercial version? I've just published that question. Just I would request all of you to answer. Do you know if the Autodesk products are free for education and there is no difference in the education and commercial version? There was one question in the chat window saying, sir, why are you using Autodesk? Why not other companies' products? See, we at ICT Academy, we being non-for-profit, second, we are supporting academia, and Autodesk is the one and only organization which made the very expensive software products free to education. So end of the day, we are teaching design. We are keen on design, teaching people design. So we thought it is good to teach design in a very, very most popular product. And of course, in our context, it's free for education. So that's what made us to initially decide we will be with Autodesk and we will go with all Autodesk products.
Just to add to on top of that, there's you see that AutoCAD is a basic things, and one of the best part of Autodesk products is the look and feel of the UI. I mean, if anybody has already worked on an AutoCAD platform, you open up any product from Autodesk products, you will see that it's very easy and quick to learn, because you will not see difference. And so you don't have to spend a lot of time in figuring it out where the tool is, what the tool is all about. Basically, you spend more in terms of quick learning how the tool works actually.
Okay, I'll just quickly, tell the results of this, this particular question of the poll. Now, if Dipankar is online, he'll be also a little surprised. See, only 45% of people say yes. That means only 45% of the audience know the products are totally free for education. More than 50% think there is always a cost. So, no, the message, or the conclusion of this as a message, as I stated, let me put it very clear. All Autodesk products, all their products, which is used for design, architecture, or mechanical, construction, and also the entertainment space. Everything, whatever products Autodesk has, it is free for education, and you get the same version or the same features what a typical commercial user will be using. So with that, I will end this poll and I will hand it over back to Ananth.
Yes, the reason because this is a very different kind of an audience, and this is because to the education community that we directly work with, we know that. I mean, now free doesn't mean free here. I mean, free in the sense it's absolutely free, but there is a different strategy that Autodesk thinks about it, because we believe in making the students ready and education students ready for the future of making, as well as for the future industries. That is where the management staff across Autodesk felt that, and this is a decision maybe a decade back. So that's where we started changing our strategies from the cost to the free kind of, for especially educational institutes. Of course, it is not commercial, and there's nothing like a scaled down version in the product. It is what the commercial people actually use is the same product. So if you look at, there are other offerings as well in terms of, but there could be some scale down in terms of the products, but we definitely don't believe in that. All right, so that was thank you, Mr. on that one. And here I really want to slightly shift the focus to help you understand how Autodesk is playing its role in the education system. So there is a prediction. I mean, what it has been predicted globally is by 2020, there will be 95 million people will lack the skills that are needed by the industry. So which is a big change in the market. And I felt that through this forum, I should be able to bring this little information to you also, that we get ready to meet those requirements and make our students ready for that industry. And if I have to tell you that, especially just in US itself, there is a 2.4 million jobs opening will be there between 2019 to 2028. And that, what does that mean is like 53 openings out of 100 will be available just in US. And imagine the global requirement that is going to be there. And one of the biggest challenge the industry or our customers who are in this domain are facing is the retiring of the age workforce and the advanced technologies, the advanced equipments to handle the advanced equipments. And also because the lack of force, the products coming into the market is also delayed. And not only that, industry is not able to find the right talent or the credentials that are being required by these customers. But we also have a very good news. I mean, we have a generation which globally predicted like it is 2.52 billion, and this generation, what we call, is anybody who is born after 1995 falls under this generation. And this generation is very, very technologically savvy. They are very curious about things to learn, and they are very active in adopting whatever changes that comes to them. So that is a good news for us to help these generation to meet the requirements of the industry. So at Autodesk, what we believe is that how can we inspire, engage, and prepare this generation so that they can be ready with the credentials that they need to, they can be ready with the technology that they need to, that can meet the industry requirements, so that when they pass out, when they go out, they are able to quickly adopt to the industry that it's asking for. But with the current student, what we face is, the current students, what they are facing is, they do not understand, or they are not aware of the power or the opportunities that are there in the manufacturing and the construction industry. They are little lack in terms of willingness towards these technologies, and they do not have the skill sets that are required by the job for them to work on the industries. So what we have to do is, we can educate them through this technology, help them understand that it's not about the IT sector, but there is a huge potential opportunities both in construction as well as manufacturing industry. And Autodesk is definitely moved to the cloud. I mean, why is that? Because we see that there are different kinds of technologies that are coming into the market, be it AR, VR, be it robotics, be it 3D printing. So Autodesk is not lagging behind. It's trying to adopt these technologies in all its product portfolios, trying to bring all that technology to the student community, to the commercial customers, for them to build better products and make the students also be aware of these advanced technologies. Just to let you know about how we are doing in terms of connecting to the education community, I'm happy to say that we are around 8+ million registered users for us. I mean, this is an information why I'm giving it to you is because as the one poll itself says that many are not aware of such informations. So that is the reason, go to the education community and see what kinds of information that is available. And not only just that, as I mentioned, I mean, we are providing a big chunk of product portfolios freely available to the students, the educators, the educational institutes, for them to work on, be innovative, enhance their skills in terms of design and make, and be ready for the industries. And there's a tons of learning resources that is available, which you can easily access through. We call it as a design academy. I'll let you know in my future slides how you could access it. And it caters to all kinds of industry segment. If you are a construction industry, you can have the courses related to the construction, mechanical, industrial equipment, consumer products, be it anything. Just go to the site and access the courses and learn through them very easily. You have video materials, you have PD documents, step-by-step procedures for you to learn. So with that, I think before going to the next topic, I would love to put one more or couple more questions, Anbu sir, if you want to put a poll and check with them.
Okay. So let me just put up one or two questions now. To work only on what? The Fusion 360 is a platform to work only on either design CAM simulation or generative design or sheet metal PCB design or rendering, drawing, animation, or all of the above. 11% say it is generative design and 11 to 12% say it is the design CAM and simulation. But I think fairly a large population of this audience are clicking all of the above.
Very good. Thank you so much for that. That was an intentional question I had to put because I just wanted to gauge, at least after my presentation, people will understand what this platform is all about and what it offers for you to work on. So that's a good answer. All of the above. Yes, it gives us everything under one platform to work through. So can I continue, Anbu sir, or you?
Please go ahead, sir.
Yes. Okay. Right. So we talked about the future of making and how Autodesk is playing its customer success and education, Autodesk and education as well. So we are not, I mean, this is one platform where ICT and Autodesk collaborated to bring you different kinds of information in this pandemic situation. It is all a new experience for all of us, working remotely, working in silos. But as I said, if you look, the era of connection is right now happening. Even though we are in a different places, we are able to connect to each other, share information, gather information, not in a design perspective, but at least an information perspective. This is what even Autodesk is trying to do in this pandemic situation. We are trying to help our education community in whatever ways we can. So we are trying to help them understand the software is freely available, where you can download that. And as I said, there's a free tons of content and curriculum is available, which can correlate to your curriculum that you're teaching in your classes. So you can correlate and help students to understand, visualize what that output would look like. And as I said, there's a design academy which contains all this curriculum and content, where you need to sign in and access the courses. And I'm happy to say that there is around 700 plus hours of content is available, readily available for you to use and work through it step-by-step process, and even not lagging behind in regularly interacting through our community forums as well. So that is where we are trying to do webinars, to where we have a direct interaction with colleges, and where we do not have, we are trying to collaborate with like ICT Academy, and then trying to reach out to our customers, help this in pandemic situation. So finally, what I really want is to help you understand, what am I taking away by attending this presentations. So one thing, there are three different things that I wanted to highlight is definitely adopt or work through the latest technology and make students ready for the industry. It's not just, I want to highlight, I highlighted students here, but I'm pretty sure the faculties available under this can definitely use these technologies for their research and patent works as well. They can think about certainly out of the box to do certain different kinds of research. So that is one thing I would like to as a takeaway, one of the point as a takeaway. And Autodesk is not saving away from what it could be as an industry partner for the future of making, not only for the future of making, how things are being made, but it's also ready for the industry 4.0. That is another takeaway you can think about, because we are constantly working on the latest technologies that can help our customers, that can help our education community, and that can help to bring better products to the market. And I would definitely like to say that Autodesk, as a thought leader in the education community, and we are supporting education community throughout our technology and helping them differentiate not just the commercial customers, but the education community through the technologies like GD. So I think with that, I am really thank you for having me present this a small bit of things. I know this is a definitely technical forum. As I again said in my previous thing, I am restricted to show certain things because of the limitations of the system, time, and everything. But what I really intend to showcase is like definitely connecting through PPT how the design is flowing, how the future of making is changing, how you can start thinking from your design aspects or from your conceptual ideation till fabrication through the product design thinking.